There's two reasons why this problem is set up really nicely to be solved by substitution. In the first equation, everything is in standard form, and you'll notice that the x has a coefficient of 1, and that would make solving for x very, very straightforward. Also in the second equation, while this isn't in standard form, this equation is already solved for y, which makes it really nice for substitution. So I am going to solve this using substitution. I like to leave a little roadmap of what I'm doing so that if I make a mistake, I can come back, see what I did, and hopefully find my mistakes. So the first thing that I would normally do is to solve one of my equations, solving equation 2 for y. That's already done for us. And when you solve one of the equations, in this case equation 2, for a variable, you'll substitute that into the other equation. So I'm going to sub this into equation 1. So when I do that, I'll have x plus 3 times whatever y is. It's going to be a big bunch of stuff that must be equal to 8. So now I need to pick up what y is equal to. That's 2x minus 9. I'll plug it in for y. And then I need to solve that equation for what's left. There's only one variable, x, so simplify both sides and isolate the variable. First thing I'll do is distribute the 3. 3 times 2x is 6x, and 3 times negative 9 is negative 27. That must equal 8. If I combine my like terms, I'll have 7x minus 27 is 8, and then I'll add 27 to both sides. This gives me 7x is equal to 35. Last thing I need to do to get x by itself is divide by 7. I'll have x is equal to 5. That's part of my solution. The original system here had two equations with two variables, so I know that my solution has to have not just an x value, but also a y value at the same time. To get that, I can substitute that value of x into either one of the original equations. And substituting back into this guy, the second equation, y equals 2x minus 9. So I'm going to go into the start equation. Is nice because that equation, again, is already solved for y. So y has to equal 2 times whatever x is, minus 9. I know that x is 5. Simplify this. 2 times 5 is 10. 10 minus 9 is 1. And then I know that x has to be equal to 5 when y is 1. So my solution is the ordered pair 5, 1.